Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The rotation barrier about AC is equal to C double bond is related to the pi bond order, pi bond strength, at that bond. A higher pi bond order means a higher barrier to rotation. The pi bond order at the indicated C is equal to C bond is reduced when the pi electrons are delocalized away from that bond into conjugated systems on both sides. More extensive conjugation, especially with electron-donating groups, spreads electron density across more atoms, lowering the pi bond order at the central bond and thus lowering the rotation barrier. Conversely, less conjugation means more localized pi electron density at the C is equal to C bond and a higher rotation barrier. Moving on to the next step. pHCH is equal to CH2. One end of the C is equal to C bond is conjugated with the phenyl ring, the other end, CH2, has no conjugation partner. The pi electrons are delocalized into only one aromatic ring. The C is equal to C bond retains relatively high pi bond character because delocalization is only on one side. Moving on to the next step. pHCH is equal to CHPH. Both ends of the C is equal to C bond are conjugated with phenyl rings. The pi electrons are delocalized into two phenyl rings symmetrically. This bilateral conjugation lowers the pi bond order at the central C is equal to C bond more than in I, giving a lower rotation barrier than I. And for the final step, pHCH is equal to CH, 4OCH3, C6H4. Both ends are conjugated with aryl groups, similar to 2, but one aryl group bears a paramethoxy, OCH3, substituent, which is a strong electron-donating group via resonance. The OCH3 group donates electron density into the ring and further into the conjugated pi system, increasing the degree of charge transfer conjugation across the C is equal to C bond. This greater delocalization further reduces the pi bond order at the indicated C is equal to C bond, giving an even lower rotation barrier than 2. Greatest pi bond localization, highest barrier, is in I, where only one-sided conjugation occurs. 2 has two phenyl groups pulling pi density, lowering the barrier further. 3 has the same two-sided conjugation as 2 plus enhanced electron donation from OCH3, further lowering the barrier. Therefore, rotation barrier I to 3. Why other options fail? B. 3 to I, incorrect, more conjugation lowers the barrier, not raises it. C. 3I2, incorrect, I cannot have a lower barrier than 2 since 2 has two-sided conjugation. D. 2I3, incorrect, I, with one-sided conjugation has a higher barrier than 2 with two-sided conjugation. Therefore, the correct answer is A. Therefore, the correct answer is option A.